Okay. In the last class, we were discussing competency-based questions on introduction to trigonometry, right? And one question it was, I think, half I solved. What was that question? Yes, please. Anyone? Yes, what was the question? So the question was, it was I think 3-mark question, right? Sorry, 2-mark. Sorry, 3-mark question. Yes. If tan theta plus sin theta is equal to m and tan theta minus sin theta is equal to n, then show that m square minus n square is equal to 4 root mn. 4 root mn. Am I right? And already we calculated the left hand side, that is n square minus n square, LHS. So what was that? M square minus n square is equal to 4 tan theta into sin theta. Am I right? Yes. Now we can calculate RHS side. RHS is 4 root m into n. 4 right as it is, under root m is tan theta plus sin theta and n is tan theta minus sin theta. Tan theta plus sin theta, tan theta minus sin theta. So it's in the form of a plus b into a minus b, right? Can I write a square minus b square? Yes? Yes. 4 into root a square tan square theta minus sin square theta. Am I right? Yes. Now 4 under root tan square theta is sin square theta minus cos square theta. Sin square theta divided by cos square theta minus sin square theta. Minus sin square theta upon 1 here. Minus sin square theta upon 1. See the numerator, both are same. Sin square theta and sin square theta. Can I take it as a common term? Yes, I will take it as a common term. 4 sin theta, because under root sin square is there. Square root get cancelled there. So only sin theta is outside. Into bracket 1 upon cos square theta minus 1. 1 upon cos square theta minus 1 upon 1. Cos square theta and 1 are in denominator. So the LCM is cos square theta. So 4 sin theta right as it is. 4 sin theta into bracket. LCM is cos square theta and 1 right as it is minus 1 into cos square theta is cos square theta. 1 minus cos square theta. Correct? So now 4 sin theta into bracket 1 minus cos square theta. Identities. First identity, sin square theta plus cos square theta is equal to 1. So 1 minus cos square theta is equal to sin square theta. So sin square theta upon cos square theta. So 4 sin theta under root sin square upon cos square is tan square theta. Tan square theta. So square root gets cancelled. 4 sin theta, come here. 4 sin theta into tan theta. Yes, 4 sin theta into tan theta. See, LHS also 4 tan theta into sin theta. Even RHS also 4 sin theta into tan theta. From equation 1 and 2, hence proved. Understood? You can call it as equation number 1 and you can call it as equation number 2. Give the conclusion from equation 1 and 2. LHS is equal to RHS, hence proved. Note down. Girls, come here. Every time you don't say what? Huh? Last one, better. Next one, how many episode? Question number 70. Yes, anybody? So, 70. Girls, how many episode? Question number 70. No one. I think you didn't try. Sana. Question number 22 we have wrote, right? Know that to the power 6 theta to be solved. Huh? Solve it. Yeah. Just speaking for Yes, sir. Next question number 17. Question number 17. Cos theta plus sin theta. Cos theta plus sin theta is equal to root 2 cos theta. Root 2 cos theta. Show that cos theta minus sin theta is equal to root 2 sin theta. You see? So we can take cos theta plus sin theta is equal to root 2 cos theta. This is the condition it is. Cos theta plus sin theta is equal to root 2 cos theta is a condition. Using this we can prove that cos theta minus sin theta is equal to root 2 sin theta. Yes sir. So given that cos theta plus sin theta is equal to under root 2 cos theta. Under root 2 cos theta. So how we can solve this? Yes, any idea? Yes? So first we can square on both sides because here under root 2 is there. So square on both sides. Square on both sides. On both sides. What we will get? Cos theta plus sin theta whole square is equal to under root 2 into cos theta whole square. Cos theta plus sin theta whole square is in the form of a plus b whole square. So what is the expansion of a plus b whole square? A square plus b square plus 2a 2 sin theta into cos theta. Under root 2 cos theta whole square is 2 cos square theta. 2 cos square theta. Am I right? Yes. Now, what can we do? This cos square theta we can transfer to right hand side. Here cos into cos theta is equal to into cos theta is equal to cos square theta minus sin square theta. Cos square theta minus sin square theta. Am I right? Yes. Now 2 sin theta into cos theta, right as it is. 2 sin theta into cos theta, right as it is. So cos square theta minus sin square theta, I can write it as a plus b into a minus b, a square minus b square form, a plus b into a minus b, cos theta plus sin theta into cos theta minus sin theta. Okay, it's now left hand side right as it is. 2 sin theta into cos theta is equal to cos theta plus sin theta is root 2 cos theta. Write it. Root 2 cos theta into cos theta minus sin theta. Because given it is given that cos theta plus sin theta is root 2 cos theta. So 1 root 2 get cancelled. Cos theta get cancelled. So remaining term root 2 sin theta is equal to cos theta minus sin theta, hence the proof. Understood? No. Same method you used? Did you use the same method? Huh? Divided by? This one is simple. Already today we came. Why? No. That's not the reason. That is the reason. Am I right? Is finished? Okay. Next question. So what is the next question? Question number 18. So this one is very simple. You can try now. Evaluate sin 30 degree plus tan 45 degree minus cosec 60 degree divided by sec 30 degree 4 minus is there actually 4 minus sec 30 degree plus cos 60 degree plus cot 45 degree. Let's do this. Only 2 minutes time I will give. Very simple one. Just substitute the values. Sin 30 degree is nothing but half. Tan 45 is 1. 4 minus sin 30 degree is half. Tan 45 is 1. Sin 60 degree root 3 upon 2. But here cosec. So reciprocal of sin is cosec. That is 2 upon root 3 whole divided by sec 30 degree cosec 60 is nothing but what? Sec 30. So that is also 2 upon root 3 and cos 60 is half plus cot 45 degree is 1. So you can take the LCM separately in numerator denominator and in denominator denominators. So you have to take the LCM. 4 minus LCM in numerator, denominator is 2 root 3. 2 how much are? 2 root 3 are. Here 1 is the denominator. So 1, 2 root 3 are. And here root 3 is already it is there. So 2 are. Root 3 into 1 is root 3 plus 2 root 3 minus 2 2s are 4 divided by 2 root 3 whole divided by same. The LCM is 2 root 3. Again LCM is 2 root 3. Root 3 2s are 2 root 3s are 1 is in denominator, so 2 root 3s are. So now 2 2s are 4. You are very early to the next class, not for this class. Hopeless. Don't know the timing. See, 10 o'clock it is now. 4 plus root 3 plus 2 root 3. Am I right? Am I right? Did you get the same answer? Huh? Yes. 2 root 3 get cancelled. So now 4 minus, here 1 root 3 is there, here 2 root 3. 3 root 3 minus 4 divided by 2 root 3 plus 1, 3 root 3 plus 4. So what's the next step? What to do? Rationalizing the denominator. Okay? Rationalize the denominator. What is the rationalizing factor? 3 root 3 minus 4. So divide and multiply by 3 root 3 minus 4. Then the numerator become 4 minus 3 root 3 minus 4 whole square divided by, it's in the form of a plus b into a minus b. That is nothing but a square minus b square. 3 root 3 square minus 4 square. Okay? So now 4 minus, see 3 root 3 minus 4 whole square in the form of a minus b whole square. So you can use the identity a square plus b square minus 2ab. A square 3 square 9, 9 3s are 27. A square plus b square 16 minus 2ab. 4 2s are 8 3s are 24 root 3 divided by 3 square is 27. 3 square is 9. Again root 3 is there. Root 3 square is under root 9. Under root 9 is nothing but 3. So 9 3s are 27. 27 minus 16. So 4 minus 27 plus 6, 33 plus 10, 43. 43 minus 24 root 3 divided by 27 minus 16. 7 minus 6, 1. 2 minus 1, 1. So it's 11. Okay. So the LCM is 11. 1 how much is 11? 1 11. 11 1. 11 4 44 minus. So actually it's bracket. It's bracket here. Okay, minus sign is for bracket. So minus 43 minus into minus plus 24 root 3. 44 minus 43 is 1 plus 24 root 3 divided by 11 is the answer. Did you get the same answer? How many of you got the same answer? Mallikarjun? Huh? Minus 4? Okay. 19th one is very simple. You can try in your home. 19th one. 4 tan theta is equal to 3 is there. 4 tan theta is equal to 3. And ask to verify or evaluate 4 sin theta minus cos theta plus 1 divided by 4 sin theta plus cos theta minus 1. So here tan theta is equal to 3 upon 4 using Pythagoras theorem, and the other side and write the functions sin theta and cos theta. Okay, simple one. Yes, next one I will solve. Question number 20. Finish? I will return. Note down fast. This next question number 20. One upon sec A, 1 upon sec A minus 1 plus 1 upon sec A plus 1 is equal to 2 cosec A into cot A. 2 cosec A into cot A. Yes, LHS we can take, and through LHS, LHS is 1 upon sec A, 1 upon sec A minus 1 plus 1 upon sec A plus 1. Okay. So what is the LCM here? Sec A plus 1 into sec A minus 1. But I am not taking the LCM because the right hand side is in the form of cosec and cot. Cosec means it is nothing but what? Sine. Correct? So this sec I will write it as a cos. 1 upon sec A is 1 upon cos A minus 1 plus sec A is 1 upon cos A plus 1. So now we can take the LCM separately. Here it is cos A and here it is cos A and 1 1. So LCM is 1. 1 upon 1 minus cos A divided by cos A. Am I right? 1 upon 1 minus cos A divided by cos A plus 1 whole divided by 1 plus cos A divided by cos A. Am I right? Yes. This cos moves to numerator. Cos A upon 1 minus cos A plus cos A upon 1 plus cos A. But LCM is not same. See, here it is 1 minus cos A. Sorry, not LCM. Denominators are not same. Here it is 1 minus cos A. Here it is 1 plus cos A. Okay. So LCM is 1 plus cos A into 1 minus cos A. So LCM 1 plus cos A into bracket 1 minus cos A. Here 1 minus cos A is already there, so you have to multiply with 1 plus cos A. Cos A into 1 plus cos A. Similarly, here already cos A is there, so we need to multiply with 1 minus cos A. So cos A into 1 minus cos A. Okay, so now simplify this one. Cos A is common in numerator, am I right? See, here also cos A and here also cos A. So take it outside. Cos A is common. Cos A into bracket 1 plus cos A is remaining. 1 plus cos A is remaining. Plus here what is remaining? 1 minus cos A is remaining. 1 minus cos A is remaining divided by 1 plus cos A into 1 minus cos A. It is in the form of A plus B into A minus B. It is nothing but A square minus B square. So 1 square minus cos square. 1 square is 1. Plus cos A minus cos A cancel. 1 plus 1, 2. So 2 times of cos A into bracket. Here it is 1 divided by 1 minus cos square is sine square a, square of sine a, sine square a. Okay. So next step, 2 upon cos a. The sine square I will split it as a sine into sine. 1 upon sine into cos a upon sine. Cos a upon sine is nothing but cot. 2 times of cot a, and 1 upon sine is nothing but cosine. So your answer is 2 cot a into cosec a, or 2 cosec a into cot a. This is your RHS. Yes, no problem. Just finish. So next 5 mark questions you can take. Section D, 5 mark questions. 5 are there. The first one is, prove that tan theta. First question. Prove that tan theta upon 1 minus tan theta minus cot theta upon 1 minus cot theta is equal to cos theta plus sin theta, cos theta plus sin theta divided by cos theta minus sin theta, cos theta plus sin theta divided by cos theta minus sin theta. So we have to take LCM first and prove, sorry, LHS first and prove RHS. So LHS side, LHS, LCM don't take now. Tan theta divided by 1 minus tan theta minus cot theta divided by 1 minus cot theta. Do not take LCM now. Why? You know, right hand side is in the form of sin and cos. So you can write tan and cot in the form of sin and cos. So tan theta is sin theta upon cos theta divided by 1 minus, again tan you can write in the form of sin and cos, sin theta upon cos theta, minus cos is cos theta upon sin theta divided by 1 minus cot is cos theta upon sin theta. Okay. So now you can take LCM in denominator. See, here it is 1 and cos theta, here it is 1 and sin theta. So LCM is cos theta, and in this equation LCM is sin theta. So remaining terms write as it is, sin theta upon cos theta whole divided by, so the LCM is cos theta, LCM is cos theta, and here it is cos theta minus sin theta minus cos theta upon sin theta whole divided by sin theta minus cos theta upon sin theta, because LCM is sin theta. Cos theta cancel. Similarly sin theta cancel. So now we can write the remaining terms. What is remain now? Sin theta upon cos theta minus sin theta minus cos theta upon sin theta minus cos theta. Okay, you see, here it is cos theta minus sin theta, but here it is sin theta minus cos theta, not a cos theta minus sin theta, but both the denominator should be same. So you can make same. How? By taking the minus sign common. If you take minus sign common here, again it will become cos theta minus sin theta. So this first equation write as it is, sin theta divided by cos theta minus sin theta. Here minus sign I am taking common, minus into minus, plus cos theta divided by cos theta minus sin theta. So in first equation also the denominator is cos theta minus sin theta, and in second equation also the denominator is cos theta minus sin theta. So LCM is cos theta minus sin theta. No need to multiply any extra terms. So directly we can write sin theta plus cos theta. If you rearrange this numerator, you will get cos theta plus sin theta divided by cos theta minus sin theta. So this is your RHS, hence the proof. Okay. Just finished. Did you complete your paper? Huh? Then you can submit tomorrow. Tomorrow also my class is there. I think tomorrow is the last day. Okay. Then again 12 days. And then for 5 days you can enjoy. Afterwards you will not get the time to enjoy. And the 24 months you will not get. So you have to decide it. Become. Nowadays you are wearing baggy shirts and t-shirts. Huh? And one more thing, very soon we will have a formative assessment 3 examination. That's in the month of November, especially for 10th standard. First week or second week of November. Sorry, first week of November. After 7 days. 23 we are going to reopen the school. 23, October 23. So 7 days revision. One more chapter I have to complete along with this. Because every exam for the 2 chapters, at least 25% of the syllabus. Okay. So one more chapter is applications of trigonometry. I am going to take applications of trigonometry. Hardly it takes 2 to 3 classes. Maximum 14 examples are there, not more than that. And explanation part is also very less there. There only we can use trigonometry functions, that's tan theta, sin theta, and along with that standard angles, 60 degree, 30 degree, like that. Okay. Not waste your time. You will have to start studying. Very soon you will have examination. Okay. Yes, sir. Next question. Question number 22. Prove that 2 cos to the power 6 theta to cos to the power 6 theta plus sin to the power 6 theta, sin to the power 6 theta minus 3 sin to the power 4 theta plus cos to the power 4 theta plus 1 is equal to 0. See the example. 2 cos to the power 6 theta plus sin to the power 6 theta minus 3 into bracket sin to the power 4 theta plus cos to the power 4 theta plus 1 is equal to 0. So you have to take LHS side and we can prove RHS, that is 0. Okay. Yes, LHS side is 2 cos to the power 6 theta plus sin to the power 6 theta minus 3 sin to the power 4 theta plus cos to the power 4 theta plus 1. This is LHS, left hand side. It looks complicated, correct? It looks a complex equation, but it's very simple. See, this sin to the 6 theta and cos to the 6 theta, we can write it as 2 cos square theta. So here big bracket I can take. Cos square theta whole cube. 2 3s are 6, correct? Plus sin square theta whole cube, bracket complete. Minus 3, this one you can write as it is. Now you can write as it is. Afterwards we will see. 3 sin to the power 4 theta plus cos to the power 4 theta plus 1. See, the first equation, cos square theta whole cube plus sin square theta whole cube, it seems like a cube plus b cube, right? A cube plus b cube. So what is the expansion of a cube plus b cube? A cube plus b cube, a plus b into a square minus ab plus b square. Again and again I am telling you, a cube minus b cube and a cube plus b cube are little different than the other identities. So do not get confused. A cube plus b cube is equal to a plus b into a square minus ab plus b square. And a cube minus b cube is a minus b into a square plus ab plus b square. Okay. Yes, here this cos square theta is a complete a and this sin square theta is a complete b. Understood? It is not a square, it's a cube, b cube. So now to write as it is into bracket, and this 2 is related to only this equation, not other equations. 2 a plus b, that is cos square theta plus sin square theta into bracket a plus b into a square we have to write now. A square is cos square square, means cos to the power 4 theta. A square plus b square sin square square sin to the power 4 theta. A square plus b square minus ab now. Minus ab is cos square theta into sin square theta, bracket complete, minus 3 sin to the power 4 theta sin to the power 4 theta plus cos to the power 4 theta plus 1. Okay, 2 into bracket. What is cos square theta plus sin square theta? 1. Cos square theta plus sin square theta is 1. So the remaining terms, cos to the power 4 theta, cos to the power 4 theta plus sin to the power 4 theta minus cos square theta into sin square theta, bracket complete, minus 3 sin to the power 4 theta plus cos to the power 4 theta plus 1. Am I right? Yes. Now what I will do? I will take cos to the power 4 theta plus sin to the power 4 theta as a one term and cos square theta minus sin square theta as another term. I mean that I am multiplying this 2 to this term and this term. Now it will 2 cos to the power 4 theta plus sin to the power 4 theta minus 2 cos square theta into sin square theta minus here 3 sin to the power 4 theta plus cos to the power 4 theta plus 1 bracket complete plus 1. Am I right? So any doubts here? Okay, now see 2 cos to the power 4 theta plus sin to the power 4 theta minus 3 cos to the power 4 theta plus sin to the power 4 theta. Both are the same terms. Like a 2a minus 3a is how much a? Minus 1a or minus a. So can I write this as minus sin to the power 4 theta plus cos to the power 4 theta minus 2 cos square theta into sin square theta plus 1. Am I right? Am I right? Yes. This minus sign is related to this whole bracket, not only for the sin to the power 4 theta, not only for the sin to the power 4 theta. So this minus sign related to both sin as well as cos. Here also minus sign is there, and here also minus sign is there. Can I take it as a common term? Common minus? Yes, minus as a common here. So inside bracket sin to the power 4 theta plus cos to the power 4 theta plus 2 sin square theta into cos square theta bracket complete plus 1. Am I right? Am I right? Just I took minus sign common. Sin to the power 4 theta right as it is. Cos to the power 4 theta right as it is. Minus sign common. So minus into minus it become plus 2 sin square theta into cos square theta. You know identities very well. Algebraic identities. A square plus b square plus 2ab is nothing but a plus b whole square. Here a is sin square. A square is sin square square. That is nothing but sin to the power 4. Here b is cos square. B square is cos square square. That is cos to the power 4. And ab sin square and cos square. So this one I will write it as minus into bracket sin square theta plus cos square theta whole square plus sin square theta plus cos square theta 1 square 1, but minus is outside, not inside of the bracket. So minus 1 plus 1 is equal to 0. So this is your RHS. Hence plus 1. Just finish. One more question. Same kind of question. So this is a 24th question. These are vulnerable questions, right? If such kind of examples comes in the exam, what we will do? Try this one. Prove that sine to the power 8 theta minus cos to the power 8 theta is equal to 1 minus 2 cos square theta, 1 minus 2 cos square theta into bracket 1 minus 2 sin square theta into 2 sin square theta into cos square theta. Do that. Sin to the power 8 theta minus cos to the power 8 theta is equal to 1 minus 2 cos square theta into bracket 1 minus 2 sin square theta into cos square theta. So you can do it. And one hint I will give. So what you can do? LHS, first you can take LHS side. That you know very well. That is not a hint. Sin to the power 8 theta minus cos to the power 8 theta. You can write it as sin to the power 4 theta whole square minus cos to the power 4 theta whole square. Apply a square minus b square identity. That is nothing but a plus b into a minus b. Let's do it. This 2 minutes time I will give. ಅಲ್ಲೇ ರಾಮ ಕ್ಲಾಸ್ ಆಯ್ತು ದಿನ ಅಂತ ಹೇಳೋದು ಇವತ್ತು ದಿನ ಅಂತ ಹೇಳೋದು ದಿನ ಸಾಂಗ್ ಮಿಕ್ಸ್ ಮಾಡ್ಕೊಳ್ತಾರ ಅವೆಲ್ಲ ಮಾತಾಡೋದು ಯೂಸ್ ಮಾಡ್ತಿದೆ ರಾಜುರ ಫೋನ್ ಮಾಡಿದ್ರಲ್ಲ ಕ್ಲಾಸ್ನಾಗಿದ್ದೆ ಬಸ್ ಹಾ ಕೈ yes your time is over now. How many episodes? Nobody, only Uttari solved. Very good. And that's not correct answer, incorrect. Yes or no, Uttari? Sin to the power 4 theta minus cos to the power 4 theta. A square minus b square identity. A square minus b square is a plus b. Sin to the power 4 theta plus cos to the power 4 theta. A plus b into a minus b. A minus b is sin to the power 4 theta plus cos to the power 4 theta. Am I right? Sorry, minus. minus, yes, sin to the power 4 theta minus cos to the power 4 theta. So first one write as it is, because we are not having any identities like a square plus b square or a to the power 4 plus b to the power 4. Am I right? So first one write as it is, sin to the power 4 theta plus cos to the power 4 theta. See, again this sin to the power 4 theta minus cos to the power 4 theta, we can write it as sin square square sin square square minus cos square square. Am I right? So again we can apply the identity a square minus b square. So sin to the power 4 theta write as it is, plus cos to the power 4 theta write as it is, a square minus b square sin square theta plus cos square theta into sin square theta minus cos square theta. So now sin square theta plus cos square theta is nothing but 1. So this one write as it is, sin to the power 4 theta plus cos to the power 4 theta into sin square theta plus cos square theta is 1 into bracket sin square theta minus cos square theta. See here it is 1 minus 2 cos square theta is there. So how can we express sin square in the form of cos square? Using the identity sin square theta plus cos square theta is equal to 1. So sin square theta is equal to 1 minus cos square. So instead of sin square theta, can I write it as 1 minus cos square theta minus cos square theta? Okay, these all things depending on proof. See here 1 minus 2 cos square theta is there. So that's what you can express that sin square in the form of cos square, that is 1 minus cos square theta minus cos square theta. So again this one write as it is, sin to the power 4 theta plus cos to the power 4 theta into bracket 1 minus cos square minus cos square, 2 times of cos square. So 1 minus 2 cos square theta. Now I can take this one, sin to the power 4 theta plus cos to the power 4 theta. You can write it as 1 minus 2 sin square theta into cos square theta. How? See, a plus b whole square is equal to a square plus b square plus 2ab. Okay, I want only a square plus b square, so I am transferring this 2ab to left hand side. A plus b whole square minus 2ab is equal to a square plus b square. Can I write a square plus b square as a plus b whole square minus 2ab? Yes or no? Huh? See, a plus b whole square is equal to a square plus b square plus 2ab. Am I right? Yes. Now what I will do? A square plus b square, I can keep it in the right hand side. Just I transfer this 2ab to left hand side. So already a plus b whole square in left hand side, and this 2ab moves to left hand side. It becomes a plus b whole square minus 2ab. Am I right or wrong? Yes. Here sin to the power 4 theta plus cos to the power 4 theta is there. This one I can write it as a sin square theta whole square plus cos square theta whole square. This is a square, this is b square. So a square plus b square, we can write it as a plus b whole square, means sin square theta plus cos square theta whole square minus 2 into sin square theta into cos square theta. Am I right? Sin square theta plus cos square theta, 1 square 1 minus 2 sin square theta into cos square theta. Understood? So sin to the power 4 theta plus cos to the power 4 theta is nothing but 1 minus 2 sin square theta into cos square theta. So this one you can write here. This whole part is there now. This part you can put here, and after that write this one, hence the proof. That's it. So any doubts? Any doubts? These are called competency based questions, complicated questions. Okay. Easily you will not get the answer. Only genius students can solve these kind of questions, not everyone. Like Utturi can solve. And his friend, one of his best friends, what's his name? That is called no? Pritam, I think, Pritam Nayak. Such outstanding students only solve these kind of examples. Every student like Mallikarjun, Kamal, they can't solve. Only outstanding students. Pritam. So we can understand. Huh? Yes, finish. Yes, next. Last question. Question number 25. In a triangle ABC, right angle dash B. In a triangle ABC, right angle dash B. In a triangle ABC, right angle at B. Imagine this is one triangle ABC, and this triangle is right angle at B. Right angle at B. BC is 7 centimeter. BC, so this is 7 centimeter, and AC minus AB. AC minus AB is equal to 1 centimeter. 1 centimeter. Find the value of cos A plus sin A. Find the value of cos A plus sin A. See, in this question, only one side is mentioned, that is 7 centimeter. BC is 7 centimeter, and it is right angled at B. Okay, sin A means angle formed, theta formed at A. So only opposite side they have given. 7 centimeter is opposite side. Okay. And one condition, AC minus AB is equal to 1 centimeter. AC minus AB. I mean hypotenuse minus adjacent is 1 centimeter. Then calculate cos A and sin. Cos A plus sin. This how to do. Such kind of example we solved, I think. It is there in exercise. There they have mentioned that plus it is. Condition was plus, but here it is minus. Can you try this? Yes. What to do? AC you can express in the form of AB. AC is equal to this one. This implies that AC is equal to 1 plus AB. 1 plus AB. Use Pythagoras theorem. Pythagoras states that in any right angle triangle, the square of hypotenuse is sum of squares of other two sides. That's all. This one is it is 24 18. Correct? 1 of 80 24. AC 25 centimeter. Now sin A plus cos A can calculate. Sin A is opposite upon hypotenuse and cos A adjacent upon hypotenuse. AB 24, right? AB 24. AC 25. AC is the longest side. Hypotenuse is the longest side in a triangle. So now cos A is opposite upon hypotenuse. Sorry, adjacent upon hypotenuse. That is 24 upon 25 plus sin A opposite 7 upon 25. 24 plus 7 31. So 31 upon 25 is your answer. So the right answer is 31 upon 25. How many have you got this? Okay, yes. So next right side heading, some applications of trigonometry. Some applications of trigonometry. Next chapter. Some applications of trigonometry. Total weightage 6 marks. Total weightage 6 marks. Only 5 marks question based on applications of trigonometry. Here we are having the options. Either or. If they will not ask 5 marks, 4 marks 1 question and 2 mark 1 question. Possibilities we can write. 1 second, wait. Five marks, 1 question, long answer type, and 1 mark, 1 question, short answer type. This is one possibility. If they will not ask 5 mark question, 1 4 mark, 4 mark, 1 question. This is also a long answer type, and 2 mark, 1 question, short answer type. Here it is very short answer type, like MCQ or 1 mark question. Here 2 mark question. So these are the possibilities. So total weightage 6 marks. Minimum 5 marks, maximum 6 marks. Okay? Yes, sir. So, what are the important concepts in applications of trigonometry? Very simple. Here, we are going to learn line of eyesight, and angle of depression, and angle of elevation, So, what is line of eyesight? Eyesight, you know, correct? Eyesight. Line of eyesight means what? One example I will give. See, here is one observer Okay, don't call him as like Utturi. Here is one observer, and he is standing in front of the tree. This is the one tree. I am not good in drawing like you. Okay, just imagine it's the one tree. And here one bird is sitting on the tree. Bird, pigeon or something sitting on the tree. So here is the observer, Utturi. He is observing the birds. Okay. He is observing the bird. Bird is sitting here. And his eyesight goes upside or downside? Upside. He is observing the tree. And in second case, he is observing the roots of the tree. So now it is downside. And what is eyesight? Line of eyesight. The horizontal line, which is near to his eyes, the horizontal line, which is near to his eyes, that is what the line of eyesight. And angle of elevation is always greater than the line of eyesight. Angle of elevation is always greater than angle of, not greater than, upside the angle of line of horizontal, and angle of elevation downside the line of eyesight. Okay? Yes, sir. Note down applications of trigonometry. Side heading you can write line of eyesight. Definition you can note down. Line of eyesight. The line of sight is the line. Drawn from the eye of an observer. The line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. The line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. The line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. So draw the one diagram here. Neat diagram you can draw. So here is the eye, the line which is horizontal to the eyesight. Okay. AB. Here AB is a line of eyesight. AB is line of eyesight. AB line of eyesight. Line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. The next right handing, the angle of elevation. Angle of elevation is the angle formed by the line of sight. With the horizontal when it is above the horizontal level. Angle of elevation definition: the angle formed by the line of sight with the horizontal when it is above the horizontal level. In that case, when we raise our head to look at the object, in that case when we raise our head to look at the object, yes, same. here it is the object. Imagine it is the object. You can call it as C. So this is a horizontal line, and now the observer looking the object. So now eyesight goes above this horizontal line. So this is called angle of elevation. Right here, theta is angle of elevation. Angle of elevation. Okay. Yes, right side in angle of depression. Angle of depression. DEPRESSION, angle of depression. Angle of depression, the angle formed by the line of sight with the horizontal. The angle formed by the line of sight with the horizontal. With the horizontal. When it is below the horizontal level. When it is below the horizontal level. That is the case. That is the case when we lower our head to look at the object. When we lower our head to look at the object. When we lower our head to look at the object. So now imagine the object is settled down to below the horizontal line. So this is horizontal line. Now object settled below the horizontal line. So observer looks down now. Okay. So his head looks down. So now it is angle of depression. Angle of depression. This is D. D is object and C is object. Okay. Yes, exercise problems I can take in next class. Can I solve now only? In the 10 minutes we have, at least 1 or 2 examples we can solve. Yes, exercise number 9.1. First question. A circus artist is climbing a 20-meter long rope, which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. See the figure 9.11. A circus artist climbing a 20-meter rope. See, it's given in the diagram. A, B, and here it is C. So AC is 20 meter. So this is the rope. A circus artist is climbing a 20-meter long rope, which is tightly stretched and tied from the top of a vertical pole. So AB is what? AB is the vertical pole. AB is pole here, and AC is the rope. AC is the rope. This rope tightly stretched from the top of the pole to the ground. If the angle made by the rope with the ground is 30 degree, angle made by the rope with the ground is 30 degree, find the height of the pole. So we need to calculate what? AB we need to calculate. Already we are having the functions sin theta, cos theta. Sin theta is equal to, how you define sin theta? Opposite upon hypotenuse, and cos theta adjacent upon hypotenuse, and tan theta opposite upon adjacent. Tan theta is opposite upon adjacent. Okay. See, in this question, the angle formed at C. Angle formed at C. Which side is opposite side? AB is the opposite side, and AC is the hypotenuse. Hypotenuse is given. Hypotenuse is given, and angle is given, and opposite is asked to calculate. Can calculate here opposite side. So which function can I use? Sin. Sin is equal to opposite upon hypotenuse. In a triangle ABC, theta is equal to 30 degree. Theta is equal to 30 degree. Sin theta is equal to opposite is AB upon hypotenuse is AC. So substitute the value. Sin 30 degree is equal to AB don't know, and AC is 20 meter. AC is 20 meter. Sin 30 is half is equal to AB upon 20. 2 ones are 2 tens are. So AB is equal to 20 meter. And sorry 10. AB is equal to 10 meter. Hence the height of the pole is 10 meter. Okay. The second question. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degrees. The distance between the foot of the tree to the point where the top touches the ground is 8 meter. Find the height of the tree is the question. A tree breaks due to storm. Okay? Yeah. Imagine there is one tree AB. AB is a tree and it breaks due to storm. Here it is a point C. It breaks at C due to storm and the top of the tree touches the ground. This part. Now this broken. This part is broken and the broken part touches the ground. Means point A touches the ground. This CA is equal to CA, correct? Broken part touches the ground and the distance between the top of the tree to the, what is this? Foot of the tree. Top of the tree to foot of the tree is how much? 8 meter. Foot of the tree and the top of the tree is 8 meter and it forms an angle of what degree? It forms an angle of 30 degree. So in this case they ask to calculate the height of the tree. Height of the tree means AB. AB is total height of the tree. AB is nothing but AC plus BC. So AC also we can calculate and BC also we can calculate. Yes sir. In a triangle ABC, theta is equal to 30 degree. Okay, theta is equal to 30 degree and AB is 8 meter, that is given. So first we need to calculate BC. What is given? Adjacent is given because angle formed here. So adjacent is given and asked to calculate opposite side as well as hypotenuse side. So first we can take tan. Tan theta is equal to opposite upon adjacent BC upon AB. So tan 30 degree is equal to BC don't know divided by AB is 8. So tan 30 is 1 upon root 3. So 1 upon root 3 is equal to BC upon 8. So cross multiplication BC is equal to 8 upon root 3. But they asked to calculate total height of the tree. Total height of the tree is nothing but AC plus BC. And this is broken. This broken part is here. AC is nothing but hypotenuse. In a triangle ABC, so theta is equal to 30 degree. Theta is equal to 30 degree. So now you can use any function, either sine or cos. Sin theta is equal to opposite BC upon hypotenuse AC. Sin 30 degree is equal to BC is 8 upon root 3 upon AC and sin 30 is half is equal to 8 upon root 3 upon AC. So this AC multiplies to 8, correct? AC upon 1 is here. AC upon 1. Otherwise, you can take this side. This become AC is equal to 8 root 3 upon into 8 root 3 into 2. So AC is equal to 16 root 3 and it is 8 upon root 3. So total height of the tree is equal to AB is equal to AC plus BC. AC is 16 root 3 and BC is 8 upon root 3. Do this. Simplify that one. Take LCM. LCM is root 3. I think 18 root 3 will do. Second answer.